Okay, in this video I'd like to do this example problem shown, and it says consider the graph G made up of vertices and edges. We've got 5 vertices A through E, and our edges are sets containing 2 vertices. Because they're sets, they're unordered, and therefore this is not a digraph. In other words, it's not a directional graph. A digraph is just short for directional graph. If I would have had single parentheses around these edges, then they would have been directed, because that would be an ordered pair. But these are just subsets. Okay, this is straightforward, I think. Let's draw the picture. A, B, C, D, E. Let's suppose we lay it out like this and see what happens when I connect these guys. I have a link from A to B, one from B to C, one from C to D, one from B to D, one from B to E, and one from C to E. Okay, draw a picture of this graph. Arrange it so no edges cross each other. Oh shoot, I've got 2 edges crossing each other here. So I'm going to go ahead and redraw it. And what I'm going to do is I'm going to kind of unfold this. I'm going to put B, or I'm going to put node D. I'm going to unfold this and bring node D up to here. And you'll see that that will work. A, B, C, D, E. And now I'll draw those same connections from A to B, B to C, C to E, B to E, B to D, and C to D. This is the same graph. Okay? How you draw it on the page doesn't matter at all as to what graph it is. It's the same set of nodes and the same set of vertices between them. Okay? So we've done it. We've done part A now. What type of graph is this? Well, it doesn't have multiple links. It doesn't have loops. And it's not directed. So this is a simple graph. Okay. Is it connected? Yes, it is connected. Okay. Again, technically, from the figure, technically we would have to make a chart that has all the nodes B, C, D, E, A, B, C, D, E. And to really prove this, we would have to draw out and show that there is a path from every node to every other node. And in this case I can do it relatively quickly. A to A is we don't need to draw paths from a node to itself, that's trivial. But from A to B you just do the path BA. Or from B to A, let's see here, I guess technically speaking. Is it going to undo my drawing? Yeah. Technically speaking, from B to A, and then from A to B. There's a single link connecting them. So that's my path. That's my my path from one to the other. From C to A, I go C, B, A. There are others. I could have gone C, D, B, A, but all I need is one. From D to A, I can go D, B, A. From E to A, I can go E, B, A. From C to B, I can just go C, B. From D to B, I go D, B. From from E to B, I can just go E, B. From D to C, I just go D, C. From E to C, I go E, C. From E to D, I go E. I got a couple choices, EBD or ECD. How about EBD? And then the ones in the upper quadrant are just the same paths reversed. So here I really did a careful job of showing that it's connected, but usually if you have a figure, C figure is enough. Okay, is it a tree? It's not a tree because we have a cycle. D, C, E, B, D. We have a cycle. We have this. Well, there's multiple cycles. We could just choose one of these little triangles as our cycle, but we also have that great big thing. All it takes is one cycle to prove that it's not a tree. So, hope that helps with this example.